Hi everyone, and thank you for taking your time to go through this new video related to detection. As you can see, you see this bed in the background. I've put myself in the children's room, which is a quiet space for me to have this video with you. Detection is actually a component or a series of components within the Moose framework that allow you to detect enemy targets and report upon them, so that you can take action on the units that have been detected. This set of modules have been developed together with the Moose community. People have been testing this together, and I would like to thank the people that have contributed in this effort. Let me walk you through this. Okay, I'm going through this presentation. It's just a presentation, but I think it makes sense to explain this in a good way, so that when you get into coding you really understand the concepts behind and how it works. So detection is basically, let a set of groups, so reconnaissance vehicles or forward air controllers, airborne or on the ground, let them detect for you enemy targets, and these detections are being done at intervals that are being specified within those components. So over time, let's say every 30 seconds or every minute, a detection run will happen. And enemy units that have been detected will be grouped according various grouping methods that have been defined within each detection class. And then after the grouping, the detection can then report the groups that have been formed towards any module or any messaging system that uses that. There's a little bit of symbols that have been used. I'm going very quickly over it. So the light green cyan are friendly, the red ones are ground hostile or air hostile, and then you get these symbols here: military wing, fixed wing, anti-tank, and so on. It doesn't really matter, just look at those colors. So the light greens are airborne or ground friendlies, and these would be ground hostile or airborne hostile. And to get into the detection methods, so the reconnaissance, you will see like this symbol most of the time, and then you see here some kind of symbols here, which is the unit, the enemy unit, and then I label them with a letter, and this is consistently taken through the presentation like this. The first thing is detection. There are certain methods that can be applied depending on the capabilities, the technical capabilities of the reconnaissance vehicle. Detection can be done visually, optically, by radar, by infrared, by EVR or data link. Actually, I'm using the normal DCS detection API. I'm using the normal DCS detection methods. There's no rocket science behind. But what I've done is added the grouping, added some filters, added some options to fine-tune the detection according to your needs and your mission design requirements. Let's look at the options that we have in the detection classes. The first option is that when a detection is being done, you could say, well, for that reconnaissance, I will only accept a valid detection if it is within a certain range. So you can specify this arc here in meters, and in this example A and B would be accepted and D would not be accepted as a detected target. The other one is accepted zones. You could say, well, the reconnaissance vehicle could detect targets. It could detect D, B and C, but I will only accept the detection of D because it's in an accept zone, right? B and C would not be accepted. So this accept zone, there are APIs available within the detection objects that will allow you to set those zones, and I can get to you that. I will explain you when I get into the coding aspects of these. Also, you could say, well, I will only accept targets when they are in a zone or when they are not in a zone. So for example, I will reject D here, but I will accept B and C because they're not in the reject zone. All right. There are other options, but they are still under construction. I'm not going into details on those. The other options that we have are looking at whether a certain unit is within a forest area or not. What is the angle towards the object? Is it in a flat area or is it in an elevated, and so on and so on. And this all influence the visibility of the detections, yeah, in real life. So what I'm trying to do is to give you a component, a framework that you can better simulate real life detections, because I think the DCS detection framework is good, but it's sometimes, I think, unrealistic. So then let's look into what are the different grouping methods that can be applied when you execute detections. And the first most easy grouping method that can be applied is units. So what is units? Well, detection units will do detection, and each unit that has been detected will become a separate entity within the detection array set. What we mean with that is within the detection objects or the detection classes report back a list called detected items, and each item is an array, right? It's like an entry in that array, and in that array each entry then has a set, a set of units of different units that belong to that item in the array detected items. Another thing is, depending on the grouping method that has been applied, the grouping could be per zone. So there's something like a zone property that can be set on a group on a detection object. So when you do detection of units, there isn't any zone available. So each unit is separately identified, but those units are individually locatable. That means that each detected item can be specified when you report it. This is the coordinate to where you need to fly. This is where these items are. Okay, so just remember, for detection units, each object is locatable, has a center, right? Second is the detected items. Each item in the list has just one unit, yeah, and there aren't any zones involved. Another method that can be used in detection is detection types. So detection types, what it does, it groups the detection results based on the type of unit that has been found. So in this case helicopters, in this case ground air to ground SAMs, right? So what you see here, and this really becomes different, is that when you look at detection types, move that a bit here, it's a bit in the way. So when you look at detection types, the list will be constructed in this way. So you got the item 1 here, which would then contain, in the set of item 1, it could contain unit A and D, and then here it would contain unit B and C in item 2. There aren't any zones. Why? Because each unit can be really dispersed at different locations, and they are grouped per type. So you could have, it's very hard to explain where is the zone and where is the center of where you need to fly to. So detection types is typically kind of a detection method that does not allow you to specify in advance where these targets are located, right? And you will see that in the task dispatching coming back when you use detection types. Detection areas is the most complicated, and I think right at the moment the most fancy and nice detection method algorithm, but it also has its disadvantages, I must say. Detection areas is basically, it will dynamically define zones, so it will detect the units, it will create groups of units within a certain range that has been specified dynamically. It will say which is the center unit of that group, of that area, and then it will add the other units that are within that area to that detected item list. And this is reflected here. So in this in this example, there would only be one detected item, which is this little parameter here. It would have D as the center, and it would have unit B and C, that's a typo. Unit B and C would be part of item 1. This kind of detection method allows for has zones, right? So you can have a zone parameter in there, and it allows you to specify where is the center of the detected item. Let me go quickly through what zones really means, because detection is done run by run, each every 30 seconds or every minute. There could be an evolution in how detections are being detected and are being reported. So what you see here in the situation is the reconnaissance vehicle is detecting a couple of units here, so it's detecting unit B, A, D and C. So the first thing that it does is it finds A and it says, well, A area 1 is created because it's the first item that I've detected, and I create an area around A, which is then called area 1. On top of that, in that area, I'm then detecting a unit B, so that B is added to that area and will become detection item 1. The area Amina. So similar here for area 2. The first item that has been found that was not in area 1 is unit D, and area 2 is being created. And then C is being detected, and C is being added to area 2. So you would have in the list here, as explained, you would have 2 items here, yeah, with the respective units added. Now watch carefully. I'm going now to the next slide and see what happens. When I do detection run 2, B would move, but would still remain in area 1. So in the next detection run, nothing changes, just B has moved. Let's go to detection run 3 and see what happens. This is interesting. There is a new unit detected, unit E, and unit E, because it's in the parameters of area 1, this will be added to area 1. Let's go to the next run, run 4. In run 4, it could be that B got destroyed or could become undetected. So what happens is the reconnaissance will report that A is still the center, but B would be removed from the detection area 1. In run number 5, this is a very important change. A would become destroyed. So now, because A is destroyed and was the center unit, see that? This can't be the center anymore. So the remaining unit in that area 1 was unit E. So E becomes the new center, and any unit identified within that new center will then be added to that area. Run 6. Here you see area 3 is being created because a new unit has been detected, unit F, outside of area 1 and 2. So unit F becomes a new area has been created, and unit F becomes the center of area 3. Now you see here unit C that was residing in area 2 is moving to area 3. So C becomes part of area 3 and is being deleted from area 2. E, which was a center, is flying to area 2. So E, area 1 is removed and E becomes part of area 2. Right. So what you see here is an evolution, and I don't want to make the presentation too long, but just remember that detection areas is a dynamic creation of areas, and allows you to define a very dynamic detection kind of method that does not bring a lot of reporting. I mean, the reporting is done by zone, so you can group logically the detected areas by zone, and then the people can just select a task. I'm going to attack area 3 or area 2 here, right? This is really nice. There could be hundreds of units in an area, depending on how wide you specify the range of that area. Yeah, I will go into further details when I'm going to, explain how task dispatching in areas using this method is being performed with sufficient detail. Okay, I'm going a bit further in what is being under development for detection probabilities. So as I said, detection off the shelf is really, very sharp, I would say. I mean, wreckers are able to detect units within seconds that are 5 kilometers away, and I don't think this is realistic. So the first thing is, depending on how far the detection the unit is from the wrecker, the accept probability would change, right? So if a detection would be done here using the DCS API, it would over time, maybe here just take 20% of chance that D would be an accepted target to be detected. And these factors are configurable within the detection object using APIs. Another one is the angle. So if you're flying a helicopter and the angle towards the target is higher than a specified amount of degrees, then it could be that the detection is becoming much more easier than when you would be, at 0 degrees or at 1 degrees, because then there's clutter, there are houses in between or anything. And in real life, this is what happens when you're in the air, and that's why helicopters search in the air of the police. They find easier those targets. So that's it, I think, for the moment. I'm going to show you now a little test mission that explains you the detection areas in a live situation, how that is working at the moment. What has been outlined here is the concept, and it's not completely being implemented yet, but the plan is to get it like this. And the reason is that this transition here, the last one, is very complicated and very unperformant at the moment, and I need to find a way to make it more performant. I think I will find it, but it just takes time to make these things. So let me demonstrate you a real life situation on how this could be working. Yeah. For this demonstration, I'm going to a mission script called DET255, DET, so you'll find it detection DET255, and open the Lua file here. I am going to do this arrangement of screen, so I will run the mission here and I will augment the discussion here. So while the mission is running, I will show you where we are within the logic. So let me quickly go through the mission. So I'm having an FAC group here, a forward air controller, blue. I'm having red targets here, which will be detected by the forward air controller. And what will happen is I'm using the detection method, detection areas. So dynamically areas will be created around these detected units here. Around 4 areas will be created. And then this unit here will drive from here to here. And while it is driving, let me go through the mission script here. So while it is driving, there are certain destroys happening of targets. So target 4 will be destroyed after 30 seconds. Target 6 will be destroyed after 60 seconds. And the target 7 will be destroyed after 90 seconds. Let me show you these targets here. So target 4, remember, target 4, that would be somewhere here. 6, 4. So this is 4, right? 6 will be here, right? And 7 will be here. Remember that. Okay, let me run the mission. I'm going in the role as Game Master. let me put this to pause. So we got target 7 here, target 3, target 4, target 5, and target 6. And this truck, target 1, is driving to here. After 30 seconds you need to, let's keep this timeline in view. And I will show you step by step what will happen. So I'm going to make the mission run now. So this is detecting targets. Now the first step here that you see, let me zoom it in. What happened now is it has detected all these targets. It has identified from these targets which are the center units that I see, and it has created an area around these center units. So target 2 is a center unit, target 3 is a center unit, so target 4 not. While here target 6 is a center unit, target 5 is a peripheral unit, and there is one area here, target 7, which has one unit in there, which is a center unit. So let's look at what the truck does when it drives to that area here. And let's watch while it's driving, because target 4 will be destroyed after 30 seconds. So let me watch till 30 seconds what is happening. So truck is driving. We have 12, 13, 14, 15, 16, and every 30 seconds there is a detection being run. Before I do that, because it's almost driving out of there, let me show you what these objects are here. Why are these triangles being put? Right? These triangles are basically tires that are being put dynamically around these detected areas. It's very difficult to show them because they have a flag, but basically, I don't know, can I show statics? Yes, I can. Here. Excellent, F12. So these tires are being put as a boundary dynamically around these areas because I had to have some visualization technique how to show that to the end users. And the API that does that is this one. Bound detected zones. Okay? The smoke that you see is smoke detected units. So every unit within an area gets a smoke. Okay, let me continue this mission, and then you'll see here probably when it gets out of bounds in the next detection run, you'll see something changing. We are at second number 24, so at second number 30 detection target 4 will be destroyed, and target 4 is this here. So it means that, well, this will be removed, but this will remain the center. Let me continue the mission. 27 seconds, 28. This is driving out of there. Here you see the destroy, and now a new detection run will happen. So what now is happening? There you go. What now is happened is after 35 seconds is that this is remaining the center, while this truck here is out of bounds here. So the recce will say, hey, I have a new target here. Sorry, a new detected target here with a new area. Okay, so that truck is driving. Between detection runs, it cannot just detect online. So every 30 seconds, the areas that have been defined are remaining in there. Yeah, so it's up to the detection runs to actually define what's happening. We are now at 57 seconds, 59. Here you go. Now this one has disappeared, so unit 6 has been removed, which was a center unit of this one. And while that is going on, this truck is driving away as well. Voila. So what happened now is this center unit is moved, and this now becomes the new center unit. Remember this model here? From here to here. Right? That's what happened. Area 1 is moved. So this is now the new center unit, but the area is remaining while this truck is still driving. Okay, so we are going now to 1 minute 11, 114, 116, 117. This truck is still driving. 24, 25. Let me speed it up a bit. Okay, so now this center unit has been removed, and as a result this area in the next detection run will be disappearing. We are now at 37 seconds. Here you go. This has disappeared, and this one here is driving into this zone. Now, in the current implementation, any center unit that has been defined and that is not destroyed, the area around each center unit will be kept, even if it drives in another zone of another center unit. So this scenario here, right? This scenario of E is not working in the real life implementation, and that is due to performance reasons. But I think I have a solution, and I need to work this out. But I can already release, very quietly, the complete implementation. It's working perfectly in the detection algorithm. So I'm keeping 4 areas instead of joining that area here. So this is a demonstration. I hope you enjoy this this concept. What is going on here? So I hope you enjoy this concept. And these are the smoking. This is the smoking that is done. The center units have get a red smoke, and the green, the peripherals get a green smoke. Now, while the unit was driving, every detection unit it had smoked, the positions. So let me conclude this video, and see you in the next video, where I'm going to explain some of the APIs that are with these detection units and go into the code of how you code this stuff.